We're going to make a position time graph for the Tumble Buggy as it moves across the screen, as you were requested to do so in our last lab. The first thing to do is create our axes. We know on the horizontal axis we're going to put time, so we can see that our time starts at about 22 seconds, a little after 22 seconds actually, and it seems to end, let's jump ahead, right about 25 seconds, right? So we'll make a horizontal axis that goes from 22 to 25 seconds. Might as well just do 1 second per deep bar there, bold bar. And we can now make our vertical axis needs to run from 0 to 100 centimeters, right? So why not do, I don't know, 10, 20, 30, 40, 50, 60, 70. That's not enough. Let's do 20, 40, 60, 80, 100. So we'll put this as 100, 80, 60, 40, 20, and 0. So let's go ahead and add in our axes. And let's label our axes. This is time in seconds, and this is horizontal position in centimeters. All right, let's get some data points. Shoot, we have one here. Let's just roll it back just slightly. Ooh, that YouTube jump is pretty big. Okay, so the front of the car is right here at 100 centimeters, right? And that is a time of 24.97 seconds. Let's make our table, time and position. So at 24.97 seconds, it is at 100 centimeters. Let's get another point. Okay, let's look right here. That's what, a 24.72 up there. And where's the front of the car? That is right at 92 centimeters, right? So we can say 24.72, 92 centimeters. Let's get another one. Uh, 24.59, is that what this is? Let's back it up a little. See if I can make that a little bit clearer. All right, here's one. 24.49, clearly. 24.49, and the front of the car is right at 82 centimeters. All right, let's get another backed up. 24.39, and the car is at 78 centimeters, and so on and so forth. We'll keep doing this, getting other data points. Well, I speed it up a little bit so I don't end up with 200 data points, but more data the better usually. So this is 24.14 seconds, and this is at 68 centimeters. Let's back it up further, get some good data on this side of the meter stick. Okay, that is 23.73, and it's at 52. 23.73, and it's at 52 centimeters, the front of the car. Let's back it up further. That's hard to read, the timer there. Let's see if we can find another spot where it's easier to read. Want to get it before 50 centimeters. That's 2360, right? Yep, 2360, and it's right at 48 centimeters. 2360, and it's at 48 centimeters. Keep our line going down here. Let's get some early data from the first half of the meter stick. How about right about there? Hard to read the timer right at that point. YouTube controls want to go full screen when I double click. I don't want to double click. Oh, but we ended up on a really nice reading. 22.87 seconds, 22.87, and we are at 19 centimeters. That's a really nice reading. Let's see if we can get anything better. Let's slow down the playback speed very much. 22.68 at 11 centimeters, 22.68 at 11 centimeters, and that's probably enough data for the time being. Okay, now we're going to plot our data. So we'll start with 100 centimeters at 24.97. That's going to be almost 25, right? I mean, right up against that line. 24.72, that's going to be pretty way up there too. 24.5. 6, 7, 8, 9. So this would be right about here. And we are at 92 centimeters. So 80, 90, right about there. And then we go to 24.49. 24, this would be 24.5. So 24.49 would be right about here. And we're looking for 82. So if this is 80, this is about 82, right about there. 24.39, so 24, this would be 24.5, 24.4, 3, 2, 1, so we'll do right under 24.4, and we're looking for 78. That will be almost 80. All right, now we're at 24.14, that's going to be very close to 24, and we're looking for 68. Well, 70 would be right about here, so we're probably talking about right there. 23.73, 23, this would be 23.5, 23.6, 7, 8, 9, 24, so 5, 6, 7, 23.7, and 52. So, go right up there, and we go to 50, just above 50. All right, 23.6. This would be 23.5, 23.6. So 23.6 is at 48. 50 is right there, so it'd be just below 50. 22.87. So 22 point, let's see, 2, 4, 6, 8, 8, 9. And we'll go up to 19, which will be just under 20, because of course our scale here is 20 for every big block. Ooh, that 20 is misplaced. It is not on the bold line. This is 20, so this dot should be down here. All right, and 22.68, so 22.567. 3.2, 4, 6, 8. So 6, 7, just under that. And we'll go up to this is 10, so this would be about 11. All right, so there we go. We have a bunch of plots. If we wanted more data, I'd say this is kind of a weak spot in our data right here between right over 23 seconds, but this will do for now. Next, we are going to create a best fit line. A best fit line is one where we try to get as many dots above the line as we have below it, and by above and below I mean on one side or other of the line, not like vertically above or below. So we'll try to put our line in such a way that we go right through the middle of most of the dots. Let's give this a shot. We'll see how this ends up. All right, seem like a good best fit line. Not too bad for using a piece of paper as a straight edge. Okay, so now we want to get velocity. Velocity is the rate of change of position with regard to time. The rate of change of position with regard to time. So how much does this move on the vertical axis given a set change in the horizontal axis? And to get that, we're going to need slope. Well, let's just pick 2 points, not data points, right? 2 points just anywhere else on the line. Let's pick easy points. Look, this hits a nice crossbar real easy. Let's use that one. And where's another easy one? This is close. Why don't we use right about, how about here? All right, we're going to make these points extra big so we know they're not data points, they are slope calculation points. So what we want to do is get our rise, make that line straight, over our run. Rise over run. So we need y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. So what is y2? Well, this is 80 and this is 100. And so this would be, see, if this is 90 here, this would be 80, 90, 100, 80, let's see, 3, 6, now let's see, 84, 88, 80, maybe it's in sixes? I don't know. Let's do some quick math to see how that's divided out. What is 20 divided by, oh, duh, 20 divided by 5 is 4, so they are in fours. So this is 84, 88, 92, 96, and then 100. So if this is 88, right under 88, we call that 87, right? So y2 would be 87. And y1, well, this is easy enough, 24, 26. Nope, sorry, 24, 28. We're counting by fours. So this would be 28. Now let's do our x values. x2 is going to be 24, and we said we're going up by 2's here. 24, 24.2, 0.4, 0.6, 24.6. So this is 24.6, and our x1 is 23.2. 23.2. So let's go ahead and plug in. Slope equals y2 is 87, y1 is 28. x2 is 24.6 minus x1 is 23.8. So let's calculate. 87 minus 28 is 59. Divided by 24.6 minus 23.8 is 0.8. And 59 divided by 0.8 is 73.75 meters per second. Now notice, that is the slope of the line. That is the rate of change. The answer was not 87 divided by 24.6, right? That's just a position it happens to be at a time. We had to get the change in position over the change in time. That's why the slope measurement.